With almost 500 sessions at Next 2018, it's understandable that you couldn't get to them all. So if you didn't see serverless all the way down, build completely serverless systems with compute, data, and machine learning, then stay tuned, because here's the rewind. What does it mean to be serverless? Serverless platforms let you run your code without worrying about the underlying infrastructure. How many machines do I need? How do I handle networking? It's taken care of for you. And serverless means scaling is automatic, both increasing in scale as more requests come in, and decreasing, all the way to 0. That means if your code isn't running, you aren't paying anything. This means serverless covers more than just compute. On GCP, we have serverless tools for AI, machine learning, databases, and more. By combining these pieces to build your application, you can create entire systems that are resilient, scale with your traffic, and let you get to market even faster because you don't have to worry about infrastructure. Here are 3 serverless app and compute tools. First is App Engine, which is designed to run an entire web backend. And with our 2nd generation runtimes, you can write your apps in an idiomatic way that's standard for each language, and App Engine will run and scale it for you. Cloud functions are small, single-purpose functions that are triggered by events in the cloud. An HTTP request, a file upload, a database change in Firestore, and more. If you're building mobile and web apps, Firebase has a broad set of tools to handle things like authentication, databases, crash reporting, notifications, and much more. For data, we have Firestore, which is a serverless, NoSQL database. It supports powerful features like real-time synchronization across clients. For doing complex data processing, Cloud Dataflow supports batch and streaming. And for big data analytics, BigQuery lets you write using standard SQL to query up to petabytes of data in minutes or even seconds. Serverless machine learning comes in 2 flavors. Cloud ML Engine, which runs your TensorFlow code and scales up and down for training and predictions. AutoML is machine learning made easy. Give AutoML your labeled images or text, and it will create machine learning models for you, as well as an API endpoint for predictions. Now, let's put it all together. How do we stitch these pieces together to create completely serverless systems? Here's an example. Let's say we have a mobile application that is built using Firestore. Now, if we need to leverage more advanced tools in Google Cloud Platform, we can set up Cloud Functions to watch and run when database changes happen in Firestore. Cloud Functions automatically run with a service account, meaning you're already authenticated and can easily make out calls to the rest of GCP to do your machine learning, big data analytics, or integration with other systems. Building these distributed serverless systems can introduce new problems. Say your app suddenly encounters a surge in traffic. If you're using Cloud Functions, that's okay, as it can scale up to meet demand. However, if those functions are all hitting some non-serverless system like a database or a third-party API, they can overwhelm that system and take it down. You can help avoid this problem by either using a serverless database, queue your requests until that system has capacity, or take advantage of throttling. For example, in Cloud Functions, you can set a max number of instances, say 100, and GCF won't scale up past 100 instances, ensuring it doesn't crush your database. Similarly, say a large increase in traffic occurs, or your system gets stuck in some loop where functions keep triggering each other. They'll scale up and up and up, and at some point it might be a financial concern. One solution is to get a planet-scale wallet, but that's not really an option for most of us. Instead, you can set programmatic budget notifications, which will alert you when you hit some budget threshold. You can get this by email, but you can also publish to PubSub, meaning you could have a cloud function that runs and shuts down unnecessary resources to avoid overwhelming your bill. For an awesome example of a highly robust, real-world serverless system, check out the Smart Parking story, either in the full talk linked in the description or in their multi-part blog series on Google Cloud Platform's blog. Don't forget to subscribe to the Google Cloud YouTube channel for more great Next Rewind content. Thanks for watching.